neurons, they're going to have lower facial weakness with drooping of the mouth, attenuation of the nasolabial fold, and drooling. Okay, but that weakness is going to be opposite to the side of the lesion. Now, you're knocking out upper motor neurons within the pathway to the upper face, but the upper face also continues to have upper motor neuron innervation from the ipsilateral side. So you may get some weakness in the upper face, but it's only partial. So if you ask the person to close their eyes tightly, they can do it. They can wrinkle on the other side, okay, on the non-involved side. But on the involved side, they may be able to close their eye, but they can't kind of cause the wrinkling, not as tightly. Okay? So the upper facial weakness is going to be partial, whereas if it was a lower motor neuron lesion, they couldn't close their eye at all. You may see some difference in wrinkling, but it's not as severe as what we saw with the lower motor neuron lesion. So the idea is with upper motor neuron lesions, the deficit is opposite, and it's predominantly lower facial. And the upper facial weakness is partial. And that's because the upper face receives bilateral upper motor neuron innervation. If you can draw this out, okay, get your whiteboard and draw it several times, like 10 times, you'll commit it to memory, you'll understand it. And this slide demonstrates the same thing. What they're trying to show is, put it up. What they're trying to show is with a lower motor neuron lesion, you have a dense semifacial weakness. Okay, on the same side. If it's upper motor neuron, the weakness is opposite contralateral, and it's predominantly lower face. And the upper facial weakness is partial. And again, these other two slides just depict the same thing. Okay? If I'm looking here, okay, where this person loses his right nasolabial fold, he's got some lower facial weakness, but he can still close his eye. That tells me immediately it's upper motor neuron. And it's on the opposite side. This is the right side of the face, it's the left side of the brain. On the other hand, if he's got a lower motor neuron lesion, he's not going to be able to close the eye. It's a dense semifacial weakness. You know, by mistake, I threw in my wife's PowerPoint here. I don't usually have this slide here, but we've talked about it. She likes to put everything down in writing, whereas I prefer just to speak and have you guys write it down. It's just a difference in approach. I like when I force you to write down stuff. That's not in the slide. So meiosis means constriction. Mydriasis means dilatation. If your pupils are unequal, it's called anisocoria. Now, I mentioned brainstem reflexes before. I said that a neurologist will come in and do testing of brainstem reflexes to assess for brain depth. The one we mentioned earlier was called the pupillary light reflex. Let's discuss another one called the corneal reflex. You know, the cornea is the window into the eye, where the white of the eye comes forward anteriorly, it turns into the cornea. So the cornea sits in front of the iris. Okay. Again, it's a brainstem reflex. So within the brainstem, there's going to be a reflex center. Doesn't involve the cortex. All reflexes have sensory and motor components. For the corneal reflex, the sensory component is V1, the trigeminal nerve, because that senses the cornea. The motor component is the seventh nerve, because it innervates the orbicularis oculi. So with the corneal reflex, what you do is you touch the cornea with perhaps a cotton swab. Okay? That touch should be sensed by V1, ophthalmic division of the trigeminal nerve, and it's going to trigger closure of the eyes, blinking. Okay? So if both eyes respond by blinking, by closing, that's a normal response. Okay? If you have a positive direct response, but an absent consensual response, for instance, that would tell you have a problem with the left seventh nerve. Yes?
I have a question. One of my friends, when she tries to close her eyes, one of them does not close all the way. And that's like been a thing since she was born.
You know what I noticed is you have a lot of friends with problems.
I think I just know a lot of people. Like let's use the term friend loosely. Not in this situation. This really is one of my friends. But
you know, sometimes when people talk about friends, they really aren't talking about friends at all.
Well, this is actually one of my friends.
Do you have a problem with closing your eyes?
No. Yep, that's me. I can't close my eyes all the way. No, like her and I like took a picture together or something, and I realized it because her eyes were closed, but then one wasn't. So I asked her if she did it on purpose because it didn't look like she did, and she said no. That if you look at like all of her pictures from when she was a child, one of her eyes doesn't close all the way. Yeah, like you see the white. Like it's enough for you to see white on one of her eyes.
Okay.
I think it's pretty creepy, but I was just wondering if that had anything to do with this.
I've never assessed that.
Okay.
It's not I'm not familiar with.
I'll bring her here. No, I'm just kidding. She would not come to this.
Lucy? All right.
Lucy. Lucy's my dog.
All right. So this would be called the corneal reflex.
Lucy's my dog. Denise was who I was talking about.
Yes.
All right. Now, we're going to move through 8 through 12 fairly quickly. 8 is the vestibulocochlear nerve. It provides innervation to the inner ear. It exits the brain right next to 7. So here's 7, here's 8. They both pass through the internal acoustic meatus, and 8 is going to provide innervation to the inner ear, which has 2 components. The cochlear, this nail-like structure, is called a cochlear. It's responsible for hearing. Okay? Whereas the semicircular canals, they provide for equilibrium.
Where's your eardrum?
Balance. That's your eardrum right there. So, what you see happening is that the vestibulocochlear nerve is going to bifurcate into 2 branches. One is going to be the cochlear branch, the other is the vestibular nerve. So one provides for hearing, the other for equilibrium. 9 is called the glossopharyngeal nerve. Glosso means what? Tongue. So tongue, throat, or tongue pharynx nerve. Okay. We said that we grouped 9, 10, and 11 together. Why? Because they exit through the internal jugular foramen together. It's a mixed nerve. It has motor and sensory components. The somatic motor component innervates the muscles involved in swallowing. It's the major nerve involved in swallowing, although 10 and 11 help. It also provides parasympathetic motor fibers to the parotid glands. Remember I said how I thought it was ironic that the 7th nerve passes through the parotid but doesn't innervate it? Okay. Well, the glossopharyngeal does. The glossopharyngeal, what's the tongue part of glossopharyngeal? It provides taste to the posterior third of the tongue. So just like 7, the glossopharyngeal tastes and salivates. Okay. Now, this business here with the carotid sinuses, these cardiovascular reflexes, we're going to forget right now. But we didn't learn them, so we don't have to forget them. We'll learn about those in A&P 2. So you'll notice, as I uploaded my PowerPoint, it doesn't have that on there.
Oh, yeah.
I don't want you to confuse yourselves. Okay. So again, glossopharyngeal, parotid gland, it innervates the muscles involved in swallowing, and it provides taste to the posterior third of the tongue. Okay. My absolute favorite nerve is the vagus. The term vagus means in Latin wanderer. It's the wanderer. Why? It's bold. It's the only cranial nerve to leave the head and neck, okay, and provide innervation to organs within the thorax and abdomen. Now, what does it do? Okay, we said it leaves, it exits the adrenal foramen. It's a mixed nerve, and so it's going to provide parasympathetic autonomic fibers to all of the organs, to most of the organs of the abdomen and the thorax and abdomen. Now, let's take the heart. Vagal innervation to the heart. What do you think that does? Is it going to speed it up or slow it down? What is it? Speed it up? No, it's going to slow it down. Remember that cranial nerves only carry parasympathetics, rest and digest. So, you ever hear the song, slow down, you move too fast. You got to make the morning last. Now, nobody?
That gets the word.
I'm sure I've heard it somewhere.
Feeling groovy. You know Simon and Garfunkel? Huh?
Who sings it?
Simon and Garfunkel.
Oh, yeah.
Okay.
I think that's beyond my time.
Okay. So it's going to slow down the heart. On the other hand, parasympathetics to the GI tract are going to increase peristalsis, help you to digest, increase intestinal and gastric secretions. Parasympathetics to the airways are going to cause bronchoconstriction. What else does it do? We said that it contributes to swallowing, but in addition, it innervates the muscles of the larynx used for speech. Okay? It also carries sensory fibers. So all of those thoracic and abdominal organs to which it provides motor innervation, it also provides sensory innervation. So if you begin to feel bloated, you know, that's vagal. You know, if you develop some gastrointestinal distress or discomfort, that's vagal. Let's go back. Are y'all familiar with The Wanderer, the song?
Probably not.
Okay, hold on. Dion. Because once you hear it, it makes it, if you listen to the words, it makes it easy to understand the Vegas.
Or something neat.
So,
I want you to listen closely to the words here.
What were they singing about the vagus nerve?
great.
Yeah, well, kind of. We'll go over it. We're not getting anything.
You clicked on the ad video.
All right, let's go back. Okay, here we go. I want you to listen closely to the words here.
Ready, Jake? Do you know who sang it?
So he roams around, and around.
Okay. So is that like...
See, he's got Sarah on the left and Jamie on the right.
Who's Jamie?
Seinfeld.
Oh. Well, I thought he was talking about Sarah.
Oh, no.
So, what do you think that means? He goes from town to town.
He has a lot of
likes to roam
children.
around. Huh?
He has a lot of children, probably.
Well, is this the kind of guy that you, Jordan, want to date?
You don't know my type.
So,
Yeah.
Douche waffle.
are you saying yes?
No, not at all.
No, he's a wanderer. He goes from town to town. How does that relate to the Vegas?
It leaves the head and neck and it goes from like organ to organ.
He goes from organ to organ. Okay, it's a wanderer.
A big stretch. And we're still gonna keep listening to it. Not approved by Abby.
They really dressed
I actually
up.
have
There's a
6
lot of them on that
kids.
little stage.
This is old school. Look at this. I like this.
That's how I look every day.
That's
Actually.
gonna be us when we do the bonus.
What?
Jordan's
You
gonna
ready,
be up front,
Ebony?
and then it's gonna
No.
be like everyone else in the back.
I'm actually
Okay.
gonna be out of
So
the
you get the
window
idea
because I'm
here.
gonna be done with this class.
He's the wanderer.
Now back to cranial nerves.
Yeah.
Sarah knew that song.
Well, you know, I'm glad. You know, somebody here is cultured.
Bonus points.
I knows it.
Did you know it?
I was telling her it was actually, that song was on one of my We Sing tapes when I was little, like those little sing-along songs.
Right. It's a good song.
It was like, it was about animals and they played that song for the cat.
Uh-huh.
No one, so I can see the little cat, like.
All right. So finally, let's go to 11, accessory. It's the only cranial nerve formed by both spinal and cranial roots. In other words, spinal roots coming up from the upper cervical spinal cord ascend through the foramen magnum and meet up with cranial roots, and they join together to form the accessory nerve. It leads from the medulla oblongata. It passes through the jugular foramen, okay? And it kind of helps out both 9 and 10. We said they travel together. In other words, it contributes to swallowing, but it's not the major innervation for those muscles. In fact, it can contribute to speech, but it's not the major muscle for those muscles of speech. That would be the vagus. But what it does do that the other two don't is it provides innervation to 2 of the important muscles in the neck and shoulder region. It innervates the sternocleidomastoid and the trapezius muscles. Okay, so let's look at Tiny here. This muscle here that originates from the occipital region of the skull and comes down upon the scapula. This is the trapezius. When we contract the upper fibers, we do this. Okay? Now, with regard to the sternocleidomastoid, contraction of the right sternocleidomastoid turns our head to the left. Contraction of the left turns our head to the right. You can feel the contraction and the movement of the head. What happens